One way to prevent overconsumption of energy is to implement variable frequency drive, for short VFD. VFD is commonly used for control of fans, pumps, and compressors. Not to mention, these applications account for 75% of all drives operating globally. The main advantage of using a VFD is that it is a variable frequency drive, which can vary the power supply to match the energy requirement of the driven equipment. This helps to save or optimize energy consumption. Not to mention, the VFD drive can radically reduce energy consumption compared to direct online, for short DOL, operation, where the DOL motor runs at full speed regardless of the demand. This means the drives also reduce NOx emissions and CO2 footprint of the system in which it was installed.
The hawker center is currently using an oversized motor, and that the motor leads to the overconsumption of energy. This causes energy wastage and increase in the energy cost. We can prevent the overconsumption of energy by changing the single oversized motor to multiple undersized motors. By switching the motor, it will prevent the system from consuming more energy than required. This is because when the motor is oversized, the system will consume more energy and will lead to overconsumption. This will then lead to an energy wastage. Most engineers use oversized motors as they believe that it is better to be safe than sorry. This is because they choose to give the device more power to cover possible variations in the system during its operation. When the motor does not work under a full load, the power consumption cost increases. Although using undersized motors create a risk that the motor will overload and overheat, our idea is to implement multiple motors instead of a single motor in order to split the load accordingly. The energy will be divided among those motors rather than relying on that single motor. Yes, it is true that we need to be safer than sorry, but we also need to think about how by oversizing the motor, the power consumption increases when it is not working under full load. I strongly believe that this idea will be beneficial to the stall owners in the long run. The multiple motors will provide just the right amount of power required rather than giving it more power. This prevents overconsumption and will greatly reduce the cost and energy wastage.
Another idea is to use green application to keep track of their energy consumption. Besides using smart meters to keep track, this application will be connected to the smart meter and can be functioned anywhere and anytime. The store owners can download the application through their phones, making it easier for them as reminders can be set to keep track of their energy consumption, and also to clean the grease filter every week before closing the shop. This is to prevent the filters from getting clogged. When the owners open the app, they will be prompted to connect the app to their smart meter. Thus, they will be able to see their total energy consumption in bar charts and also in different color codes. The green application will also provide alternative solutions for higher energy consumption by trying to find the source of problems. This will allow store owners to have lesser problems to face. In conclusion, by installing green application, store owners would be able to track their energy consumption anywhere and anytime. Reminders would have a great impact as store owners are always busy and do not have the time to keep referring to the smart meter. And providing alternative solutions can also benefit the store owners as they do not have the time to go through the trouble of seeking solutions which might just add stress to them.
For our last idea, we were trying to find a new innovative way to turn on and off the exhaust system. Currently, the store tenants are using a simple switch that is connected to the overload contactor. Our idea is to use an Arduino to program an ultrasonic sensor to make this whole system automatic. So how does it work? An ultrasonic sensor uses sonar to detect the distance. These sensors are highly accurate and give consistent reading. With it connected to the Arduino, all we need now are the codes. A simplified version of what the code does. The sensor will constantly read the distance, So what we have to do is set some sort of limit. This limit distance acts as an activation. And we will now also need a timer. So when someone stands within a certain distance and time, for example, under 35 cm and 30 seconds, this will activate the exhaust system. It will be the same for turning the system off, just the opposite. When no one stands near the limit distance for a certain amount of time, the exhaust system will turn off. This whole system can be about the same size as a wallet and will be placed at the stove around the waist height for easy detection. The Arduino ultrasonic sensor combats the common issue store tenants are facing, which is exhaust fans operating for long periods of time. Now that the system is automatic, the store tenants don't really have to worry about that. Exhaust fans will only turn on when someone is in front of the stove and will be off most of the time. This will also mitigate the power trip problem as power wouldn't be constantly drawn and will drastically help with the loud fans.